Alright, so this is another lysine question, right? Let's run through. Okay, so this lysine amino acid, I'm gonna say a few things first. So this is a carboxylic acid, all right, and this is a carbon. We call this alpha carbon, right? The carbon that's next to the main functional group, which is the acid. Yeah, it's called alpha carbon. I'm just gonna say that this is the main chain, right, of the amino acid, and this is actually the side chain, right? This is the side chain. Normally we write it as R group. Okay, so there's this is the amino group, but it's on the side chain, and this amino group is, we say, is on the main chain. All right, so let's run through. Okay, so maybe I'm just going to draw everything nicely again. So this first one, I'm going to call it A1. It is completely protonated. This is in a very acidic medium, so I'm call it A1. So I wrote it over here. This is the beginning of the graph. All right, so if you remember, this acid group has a pKa of 2.2, right? 2.2. This is the most acidic one. So the next most acidic group is this one here, the conjugate acid of the main amino group. So on the main chain, I mean. So this one, we know that, which I went through already, this pKa 9.0, the next most acidic, and the R group, this R group here, right? The R group, this NH3 plus, is the weakest acid. So I'm going to write down pKa 10.5. All right. Okay. So once you add a base, right? Add sodium hydroxide. The most acidic one will get neutralized first. So I'm just going to draw this. This is what happens, right? The most acidic group, which is COH, will lose the H plus and become CO minus. I'm going to call this B. In fact, it's already written down for you. So this is B. Okay, see that? Okay, the next equivalence point is actually this one here, C. So very quickly, so the next acidic group that will be the neutralized will be this one here. This is the next most acidic group, which means it'll be able to lose the H plus more easily than the NH3 on the side chain. Yeah. So this one becomes NH2, right? And this is I say C over here. All right, so let me just circle. So this is the next equivalence point. Okay, the graph didn't show the last equivalence point, but I'll just let it be. Okay, which is actually D. Like if you have to draw it out like that, this is probably D, and this is the one. Okay, the last acid will be neutralized. Yeah. Okay, let's run through the answers now. Which statements are correct with respect to the curve above? The alpha amino group has a pK value of 10.5. What I mean by the alpha amino group? Okay, what it means is this. So this is the alpha carbon. All right, so this alpha carbon. All right, so they say the alpha amino group is actually talking about this amino group. Okay, but they say has a pKa of 10.5. But anyway, firstly, the alpha amino group actually is being protonated. So once it's being protonated, it's an acid, but actually has a pKa of 9.0. Okay, 9.0. So this one say 10.5, so it's actually wrong. Okay, equal amounts of these two were present at point A. So point A, right, you have equal amount, you have an equal amount or equal concentration of A1 and B. All right, which means these two, right, equal amount A1 and B. So this is this part. So I can see that this is A1, all right, this one that they've drawn, but this one looks a bit strange. All right, so what is B? B, this part here is let me see. Okay, this part here is supposed to be NH3 plus. All right, and this one's supposed to be CO minus. Can you see that? Okay, but it's not, so this one is also out. Right, so you have A1, but they didn't draw B for you. Okay, the major species present at point C has no net charge. So let's look at point C. Point C is your zwitter ion. That's right. Okay, this is your zwitter ion. So it seems that this one doesn't have any net charge. So the answer is definitely correct for point C. The major species present at point B will migrate towards the cathode of a electrolytic cell. So cations will migrate to the cathode. So if you look at point B, let's look at point B. Okay, point B, what's the net charge? There's a plus here, there's a plus here, and there's a minus. Can you see that? So the net charge is still a plus, right? So we can take it to be a cation. So cation will migrate towards the cathode, right, which is the negative electrode. So this is definitely correct. So the answer is C. Okay, so the answer is C for this question, right? Okay, so lysine questions are quite kind of popular.